Today we begin the probability unit, and in this lesson we're going to be learning about permutations and combinations. We're going to start by looking at the fundamental counting principle. With the fundamental counting principle, we can find the total possible number of ways that something can be arranged. So, as an example, we have a local diner, and at the diner they offer 3 entrees, 6 side dishes, and 4 drinks for a particular special. So, how many meal choices are there? So, for the entrees, we have 3 choices. For the sides, we've got 6 choices, and we'll suppose you can only pick one side. And for the drinks, there are 4. So the fundamental counting principle says we can multiply 3 times 6 times 4, and that will give us the total number of ways that we could have lunch. So this would be 6 times 3, which is 18, times 4, 72 choices. This next one, I changed it up a little bit compared to what you've got in your notes. So, suppose a license plate consists of 3 letters, excluding O and I, followed by 4 numbers. Now, of course, the reason why they might exclude O and I is because it would look like, at a quick glance, the numbers 0 or 1. So this way, if you know that you saw something that looks like either an O or a 0, you know that it's going to be a 0. Now, how many different license plates are possible? For simplicity's sake for this problem, we're going to ignore the order of the characters. Of course, when you have a license plate, order matters, but this is going to simplify things for now. So, let me switch back there. Oops. Add a period there. Back to the pen. So, for our first spot, we would have 7 different characters, and the 3 of them are going to be letters. So since there are 26 letters in our alphabet, we're going to exclude 2 of them, meaning there'll be 24 possibilities. Now, it doesn't say that we can't repeat a letter or repeat a number, so the second letter could have 24 possibilities, and same with the third. 10 digits, so each of these numbers could be any one of 10. So if we multiply those together, then we should get the total number of combinations of letters and numbers for these Michigan plates. And so that would give us 138,240,000. That should all be, of course, one number. Now we know that with Michigan license plates, you've got lots of other possible combinations because we have license plates where you can create your own combination of letters and numbers, or spell out words or things like that. So, of course, in reality, this is going to be something different. But the example shows you how to do a problem like it. Next up, we've got permutations. A permutation is a selection of a group of objects in which order is important. So, examples that we're going to see below might involve first, second, and third place. It might be, well, there's a number of them. We'll take a look at one down below. Next, I'd like to remind you about what a factorial is. A factorial in math uses the exclamation point symbol. It's a product of a number and the natural numbers that are less. So I'd like you to scribble out that word 1 there because I think it kind of makes things a bit more confusing. For example, 5 factorial would look like 5 with an exclamation mark. And that's going to be the product of the number and the natural numbers that are less than it. Now the natural numbers are 1, 2, 3, 4, 5, and so on, going up. So the ones less than it are 4, 3, 2, and 1. Multiply those out, and we get 120. Another side note, if you ever have to evaluate 0 factorial, that is defined to be 1. Number 1. So just so you know that in advance. So there are a couple ways to do a permutation. One of them uses the fundamental counting principle, and the other uses a formula. So, in this example, we have a group of 8 marathoners in the Olympics. They're vying for gold, silver, and bronze. How many ways can the medals be awarded? So let's have this box represent gold, then 8, then silver, then bronze. And also I'd like to point out here that there's a little bad grammar that I'm going to fix. Let me bounce out here. A group of 8 marathoners. That looks a little better. This group of marathoners, they're all vying for gold. And so there are 8 different possibilities for gold. Now, once somebody wins gold, then your options for silver are limited. So now you've only got 7 possibilities for silver and 6 possibilities for bronze. So using the fundamental counting principle, that would give us 8 times 7 times 6, which if you multiply that out, would be 336 different permutations of gold, silver, and bronze winners. Now a second way we can do this is using a formula. The formula involves a number of permutations where R is the number of spots that you're taking. So in this case, 3 spots. And we would use the formula n factorial up top. Now n is the number of elements that you're choosing from. So for the marathoners example, that would be 8. And then R represents the number of spots that you're taking. So the language that you might see in a book is that these are being taken R at a time. In other words, the 8 marathoners are being taken in groups of 3 at a time. Also, you might see the formula written with a little n in front. So n is the number of elements overall, and then R is the number that you're choosing. So the way that we use the formula is like this. Let me erase these so we've got some room to write. So up top is our number in our whole group, which is 8. So you do 8 factorial. Then on the bottom is 8 minus 3 factorial. Now here's how we can simplify this. Down beneath, inside the parentheses, 8 minus 3 is 5, so we've got 8 factorial over 5 factorial. Now look how we can simplify the top. 8 factorial is 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1, which I'm just going to write as 5 factorial. then on the bottom is still 5 factorial. Clear for you. Is 5 factorial. So we've got a 5 factorial on the top and a 5 factorial on the bottom. Those simplify out. And so up top we've got 8 times 7 times 6, which is 336. On the bottom we have just 1. Divide those out and we get 336, just like we did with the fundamental counting principle. In this next example, we're asked how many ways a 4-digit number can be formed using digits 5 through 9 if each digit can be used only once. So there are 5, 6, 7, 8, 9, 5 digits. And so in this first spot, we would have 5 options. If each number can be used only once, the second spot would have 4 options, and then 3, and then 2. So using the fundamental counting principle, 5 times 4 times 3 times 2, multiply that out, and we get 120. Next up, we've got combinations. Now, a combination is a grouping of items in which the order does not matter. Because order doesn't matter, generally we're going to have fewer ways to select items than when order doesn't matter. Or sorry, we would have fewer ways to select items when order doesn't matter than we would if order does matter, like it does in permutations. So there are generally fewer ways. Now, a couple examples to illustrate the point. How many ways can the letters A, B, and C be arranged if order matters? So this is a permutation type question. So we would have 3 spots. The first spot could be A, B, or C. The second could be either of the other 2 letters. And then the third spot, once you've picked the first 2, well, you only got 1 choice there. So there would be 6 ways if order matters with permutations. Now, how many combinations of the letters A, B, and C can be arranged? Now, in a combination, order does not matter. So, with that definition, the number of ways that we can combine A, B, and C, well, there's just 1. Doesn't matter if you do ABC, CBA, ACB, etc. That's still just a single combination. So in this example, we can see that there are fewer ways to make a combination of A, B, and C than there is to make a permutation of A, B, and C. So now the formula, sometimes you'll see a little n there. We use n factorial up top. And just like we did, you see up here, n minus r factorial in the bottom, but we've also got an r factorial down in the bottom here. That's going to cause our answer to become smaller in general when we're dividing by another factor in the denominator. Now let's use this formula to answer this question about Farmer Pete. He's going to butcher 3 chickens for Sunday dinner. How many groups of 3 chickens can Farmer Pete butcher out of his flock of 11? So it doesn't matter what order he does them in. We only want to find the number of combinations. So, there's a flock of 11. We have 11 as our number of elements, and then our r is 3. So we have 3 factorial times 11 minus 3 factorial. So that would be 11 factorial over 3 factorial times 8 factorial. Now this 11 factorial can simplify to 11 times 10 times 9 times 8 factorial.